to avoid that abandoned and damaged generator after a year, after 6 months. So first off, thinking about our system operations and maintenance. In most cases, for a solar system, the operation and maintenance of the system itself, the tank, the lines, the chlorination is very similar to what it would be for a genset or an AC system, although this may represent a significant increase in complexity versus a hand pump, right? This may involve a technician that really needs to be, on a daily basis at least, looking at the system, making sure things are in good working order. What is solar specific, as we mentioned in that very first module, is making sure the panels are kept clean. It doesn't need to be anything apart from water and a soft cloth, but it's absolutely critical. A little bit of shade on the panels or a little bit of dirt can severely affect the output of electricity and cause complaints. So if you've installed a system and a community calls you to complain that, oh, it's not delivering the same amount of water as it used to, the first question should, of course, be, have you been cleaning the panels? With the passage of time, we've certainly seen panels where people aren't cleaning them, and there's buildup even of lichens, of moss, of sort of thick deposits that require much more careful cleaning than if they had simply been going there on a weekly basis with a bucket of water and a soft cloth. So making sure that we have a system that has payment not only for the materials that may be needed, for example, chlorine tablets or liquid chlorine to treat the water, but to also pay for labor, right? This is one of the big takeaways from managed systems across the world, regardless of what the management system is that no one will do work for long for free. Technicians for the systems need to receive some sort of stipend in order to ensure adequate maintenance. And ideally, other people who may be investing time in the system, for example, your treasurer or your accountant for the system that's taking in payment from users, should also receive some sort of stipend, A, to motivate them to do the best possible job, and B, there's actually a lot of research showing that people are less likely to embezzle funds when they are receiving some sort of stipend. So we need to make sure that whatever our user fees are for the system are paying for its regular upkeep, both labor and materials, and for those long-term capital CapManX costs. And of course, know that regardless of how much training we're doing when we kick the system off, right, how well we've prepared the water committee, the water board, whatever management system may be in place to appropriately manage their system, there will always be some problem that is beyond their capacity, just like there would be for a genset, right? We wouldn't expect a community to be able to dismantle their own genset and get their own spare parts. So just like it is for solar, where is their specialized capacity to do that maintenance? And where is that capacity located, right? If it's the same as a genset, that may be a wash. That is to say, if a genset also requires you to go to the capital or to a large area, population area to get spare pieces, solar may be just the same, and so you're no worse off. But in other cases, perhaps you have to go to Kampala to get spare parts for your solar system. That may be more problematic. There may be a lesser offer of qualified parts, qualified technicians for solar. So we need to consider that technological backstopping when we consider installing a solar system. Additionally, as we discussed before, how do we make sure our system is really designed for aspirational demand? If we're upgrading from a hand pump, and if we're pairing that upgrade with increased water tariffs, right, or the same tariff per liter, but obviously more use of water, users may also demand a higher quality of water. So is this a chance for us to integrate chlorination if we're not chlorinating our systems currently? If we have other contaminants in our water that perhaps we've not dealt with before, if we have hardness, if we have iron, which I've seen being a serious problem in some areas of southern Uganda, if we have other problems that are perhaps not health risks but are annoying to consumers, is perhaps integrating solar the moment that we should also be consider treating those, right? People may be willing to tolerate the bad taste of iron in their water when they're gathering free water from a hand pump. but perhaps if you're paying for solar access, users are going to demand that water treatment. So how do we consider water treatment that may be necessary as we design a solar system? We need to consider as we expand our distribution systems, perhaps beyond single point distribution, per person consumption will also go up. But as per person consumption goes up, we're really seeing greater quality of life improvements. And in many cases, we're seeing more willingness to pay. Our experience across Latin America has been that when we upgrade from shared tap stands, multiple point access, to household access, willingness to pay actually increases significantly, right? The reduced drudgery, the fact that you don't have to haul a bucket or a jerry can from a tap stand to your house, even if it's within sphere standards, is a real benefit to families, one that's hard to establish in some cases just in time savings, right? And the additional motivation that may cause for families to pay is very strong in our experience. So while we understand there may be some hesitancy that managing household access systems is more complicated, and here we really do want to push for the use of water meters, for the use of monthly readings, even more often readings, the willingness to pay of families can significantly increase when there is household access. And finally, as we think about aspirational demand, consider that when we do add on-site water access to a community, that may impact local sediment patterns. We've certainly seen in dry areas, drought-prone areas of Nicaragua, that many people will actually migrate to communities that have water systems that are online all the time. So considering the population may actually increase abruptly, even in communities where previous growth has been fairly stable, based strictly on water access, right? We should, of course, look for local examples, right? Don't take this case from half a world away as guidance, but certainly consider that more water access may change how people are living or where people are living. How should we avoid common modes of failure? One, we need to avoid overpumping, right? Damaging your aquifer by overpumping, as we mentioned, those yield tests are absolutely critical, because if we overpump an aquifer, we can draw in sediment, we can draw in contaminants, we can impact surrounding resources if we have other wells that are nearby that are drawing from the same underground aquifer. And of course, as we draw in contaminants or as we run our pump dry, we may damage it beyond repair. So emphasizing again the importance of doing those yield tests, the importance of doing those drawdown tests, and ideally communicating that to the community, to local authorities, leaving that in some place really registered in a very clear and understandable way, so that if a pump is changed out in the future by some other actor, that data isn't lost, right? We can really communicate that, no, this was the hard limit on this well in year 2022. And so when someone comes along in 2025 and wants to install a new pump, they don't accidentally install one too large for the source and end up running it dry. Additionally, since our solar water pumping systems are designed for those worst month conditions, as we finish up the design, we need to make sure that in our month of greatest solar radiation, we aren't accidentally overpumping our resource, right? So just to double check, in general, we're not going to see too terrible of a variation between our worst and our best month, but there may be areas where you're seeing perhaps twice the solar resource. And so we want to make sure that we're not accidentally overpumping our well by virtue of having designed it to pump sufficiently during the rainy season, during the lowest energy season. And finally, as we want to think about managing our demand at our point of use, we also want to invest in loss controls elsewhere. A very common error seen in a lot of solar water pumping systems is small reservoirs, and that means that we're overpumping and wasting water. The water is just running out the top of our reservoirs, which means A, we're not capturing useful water, and B, we're running the pump unnecessarily. So an automatic shutoff, something like what's pictured here, a simple float valve and a pressure switch, This is a $30 component, right? When you were running an AC system, perhaps a $100 component when we're running a solar system, but one that really can avoid a lot of messy situations. Not only we're wasting water, we're also in many cases creating muddy areas where there's no need for them. So make sure we have this, make sure our pump has integrated run dry sensors, make sure we have water meters, both a macrometer at the exit for our tanks and micrometers at our points of consumption, so that we're really controlling leaks. Because another way that we're really seeing systems fail is when they're quote unquote undersized. Sometimes they're undersized because we have uncontrolled use. No pump is going to be able to meet your demand if you have 50% system leaks, if you have 90% leaks in your distribution system, like we've seen in some gravity systems here in Ecuador, or if you have open taps because there's no water metering, right? Many families like having the water open all day. In some areas where there's traditionally been access to rainwater, it's a pleasant sensation for families to have that open all day. And of course, you can run through 20, 30 cubic meters a day through a single tap stand if it's open. So really making sure that we have loss control everywhere it's possible, right? Those investments will pay for themselves very quickly in terms of being able to manage the amount of water your system is actually moving. Another common fear, something we saw during our survey, I think 3 of the 24 overall respondents really worried about whether solar water pumping would respond during the rainiest months of the year. As you can see, we've done a lot of design work to really avoid that happening, right? We design for our worst month of solar radiation. We size our reservoir for a full day's consumption so that even if we're not pumping adequately, we're using the resource or we're using the stored resources from previous days. But we also want to really make sure our pump choice is made carefully. In these charts, we can see, right? The orange line is our solar radiation during a perfectly sunny day, no clouds. A helicoidal or a positive displacement pump is this line, so we can see our water production more or less follows our solar. And a centrifugal pump starts a little later, right? Needs more of a solar resource to spool up, to really hit the sufficient speed to pump, but will eventually get us about the same quantity of water as a helicoidal pump. That's not the case on a cloudier day, right? Here we see a day with passing clouds, right? We only hit peak sun here in about 2 in the afternoon. And you can see the difference. Our helicoidal pump starts much slower, but is pumping during most hours of the day. But the centrifugal pump sends nothing, right? Until we really hit this peak solar resource, our centrifugal pump is not reaching sufficient RPM to move water. So making sure that we're using the right kind of pump can be very critical if we have real worries about, will we have water during the rainy season, right? Make sure we're, whenever possible, that means smaller systems, using direct DC pumps to avoid these complications, right? Really use the thing that'll move water even under less than ideal considerations. And finally, no system is infallible. If we're forced to use lower quality components, particularly lower quality solar panels, may not produce all the power that's on the nameplate. So make sure we're oversizing gently. Some people would like to apply a 10% or 20% oversizing if you're using sort of unknown quantity brands, right? If that's what you're forced to use because of cost or because of distribution considerations, you may need to oversize. Your panels may not produce what they say they produce, but it's easier to use quality components, right? We know there are some problems in the area with falsification of high quality brands. So as much as is possible, we want to use authorized suppliers. We want to use suppliers we've worked with and that have a track record of many years of success. And even in those cases, right, sometimes imitations can be very, very convincing. So many of those quality manufacturers will actually have websites that allow you to check barcodes or check product ID numbers and make sure that you're buying a legitimate product. So as much as is possible, and especially for these larger investments, double check to make sure that you're really getting quality components. Going back to a question we had earlier, PV panel theft has become less common now as PV technology is more widespread. Panels are perhaps less attractive to steal now than they used to be. But how, right? While we can't ever prevent theft 100%, we can dissuade it. We can use special bolts, right? Use bolts with a head pattern that is not easy to find, right? That require a special tool. Or use standard bolts, and as I was mentioning, weld a small strap of metal over them so that stealing a panel means you need to go out there with a hacksaw, remove the welds, then use a wrench, right? Make life hard on thieves. Another way to do it is to really get community buy-in and have the community participate in construction of the system. If everyone feels like they have sweat equity or cash invested in their own water system, they may be more willing to watch out for theft. They may be more willing to report if their neighbor has a solar panel that has appeared suddenly when another one has disappeared from the water system. So make sure the community is really helping you in ensuring that your water system is well protected, sited in an area of high traffic, sited in an area where it can be seen, maybe light the area at night, right? The power demands for lighting are relatively limited. You can install a dedicated system with a battery for that. And of course, install fencing, and in the worst case scenario, even guards, perhaps at night, if you have a very theft-prone area. Depending on the size of your system and depending on the costs for lightning protection in the area, lightning protection may be a worthwhile investment. But of course, we don't want to be spending more on a lightning arrestor than we are on the panels it protects. And finally, make sure that what we're building is really thinking about the operator, right? This is an example of a system built by a local government in Peru. And cleaning these tanks is a death-defying feat, right? Hiking up onto this platform that has no handrails, you have to hop up on top of the tank and then lower yourself into it in order to clean the tank internally. So that means you need a person in relatively good physical shape. You have this sort of doubtful little wooden ladder up here on top of the towers. And that means that this community is less likely to be performing this O&M task, right? Even a paid operator is not going to be very happy about doing an O&M task that puts their health and safety at risk. And so a slightly larger initial investment on fall protection, on handrails, can really pay for itself in terms of making O&M something that's more likely to happen. So really thinking about not only solid system design, but operator safety and operator sort of happiness with performing their operational tasks can be an important part of last sort of punch list system construction. So with that, we really want to open it up, trying to stay on time. I know we've got about 5 minutes here, but open it up for one last round of questions, comments on anything we've seen today. Beneville will be sharing a little more here about a post-course survey. We'd really love your feedback on this session. And of course, that you should feel free to reach out to us, to Green Empowerment, if you've got doubts, if you've got feedback, and of course, if you'd like any additional changes on the tools or on the resources we're sharing today. I don't know, Beneville, if you'd like to add anything here.